I'm doing the Edexcel A-level past paper. This one's January 2023. Question 7, which deals with trigonometry and integration. On the right here is, I've previously worked out the questions. So the way that I'm doing these videos at the moment is I previously work out the questions. And then if you're somebody who just sort of wants a little bit more time on the question, you can look through if you're just somebody who wants to look at the answers, you can scroll through the video now and just pause it as needed. So I'm just going to scroll through this at first. So just to look at my previously written answer. So that was question 7A. And on this side, the rest of question 7A. And then question 7B going down. So just to have that. Okay. But if you need extra help, I'm going to go through the question step by step now. So just fix that. Okay. Question 7. So it gives you a curve with this equation. So we're looking at question 7A first. The equation that we're working with is this one. So it's x equals. So just first notice that that is an x equals something, not y equals something. So the first thing I would look at is that. So x equals tan y minus pi over 6. Okay. Number A, just to look at the restrictions. So they've given the restriction that y is between minus pi over 3 and 2 pi over 3, not including either. So we'll look at this restriction at the end. Okay, always come back to your restrictions at the end of the question. So luckily they've helped you out because they've said show that dy dx is this. So note that if we differentiate this straight away, it would be dx dy because it's differentiating x with respect to y. So just notice that that's what we would get if we differentiated this equation straight away. So we also need to rearrange it to be what we really want is dy dx. Okay, so a few different things that you can do for that. One way is you can just get dx dy and then flip it around, because obviously dx dy is just upside down dy dx. So that's not equal. I'm just going to take that out because that looks very misleading in the middle there. So one way is to just get dx dy and flip it around. So let's take a look at that. That would be my first go-to. I think that's probably how I did it before. Let's see if that works. So a few trig rules that you have to memorize. I have them written down here. These are just things that are rearranged. But the first thing that we know for sure is that if you have tan of an angle in your f of x, then your f dash of x is going to be, your first derivative is going to be sec squared x, or sec squared theta. So this, you can work it out yourself, but I just have it memorized at this stage. So we're using this rule first. Let's take a look. So I treat these as kind of like a chain rule. If I have, this is everything inside the bracket is like a function inside a function. So my inside function is this, and my outside function is this thing. Okay. So if we had, like, for example, if we had 2x to the power of 1, then we know that the first derivative would be equal to minus 1 from 1, that's 0. So it'll just be 2. So when you're finding the first derivative of a function inside a function, which is what we have with the green and purple, it's the same thing, only we use the chain rule, which means you have to times this, everything inside the bracket. We need the first derivative of everything inside the bracket. Okay, you times it, and that's just the chain rule. It's very intuitive. A lot of teachers teach the substitution method. That's fine. Works really well. But what I prefer to teach it with color. So the way I look at it is you first derive everything outside the bracket. So you would say, if this is tan, it becomes sec, and the a value is the same. By a value, that's the 3 is the a value. So you just bring down the a value. So we're doing dx dy. Dx dy equals to 3. A value is the same. Sec squared, because it would have been sec squared x. Then everything in the brackets is the same. So you don't change anything. And then 1 minus 1. Okay. So that would make that, oh, no. That's incorrect. So common error that my students make, that I also make, is that with trig functions, when you have the original tan x, then the first derivative will just be the whole thing exactly the same. So you don't have to minus 1 from that. So it's exactly the same thing. Okay. So restart that. So it would just, if this was 3 tan theta, it would just be 3 sec squared theta. But since we're doing the chain rule, it will be 3 tan, everything exactly the same. And we times by the first derivative of the purple, the green, the first derivative of the green function. And that would just be 1. Okay. So obviously in this case, you end up with the same thing, but I just want to show where this 1 comes from in my working. So we, 1 being, if I were to color code it, this 1 being when you have y minus pi over 6 as your function, then the first derivative of that function will be, we take the y will just be 1 minus 1 and 1 times 1. So it's just 1. And then this falls away because the constant term falls away when you derive. Okay. That's this one over here. So now we have a function for dx dy. What can we do with it? Well, we want dy dx. So obviously, in order to get dy dx, we can flip it over. So dy dx is equal to, if this was all over 1, it will be 1 over 3 tan y minus pi over 6. Now, I just wanted to go through all of this because this is what, my students and myself would do in an exam. So if you, if you practice and whatever, this is what most of my students would go for. Okay. Now, this is wrong. And the reason this is wrong is because in the question, if we take a look at the format that they've given us, there's an X in the answer. So if you take a look at our format, we have a Y in the answer. Okay. So this is dy dx. So this is correct. But we don't want dy dx with a Y in. We want dy dx in terms of X only. So this whole method doesn't work for this question. Okay, so now what do we do? So let's take a look. So I looked at it in a couple of different ways. One way you can look at it is you can treat this whole thing as a trig triangle. So let's take a look at that. We we got our dx dy as 3 sec squared, this whole thing. Okay. So we got our dx dy as this whole thing. Now, this, just to bear this in mind, but I'm going to start with the dy dx at the top, and I'm going to make myself a triangle. So say we had a baby triangle with tan theta. I'll draw it like this. If we look at the information that was given in the question, we can see that 3 tan theta is equal to x. Now I'm interchanging theta here. So just to look at my working, I'm just going to write this in for you. So what I'm doing is I'm saying let y minus pi over 6 equal theta, just to make it easier to draw. Okay, so I've already done that automatically just for the working. So I've just changed this whole bracket into theta for easy access. Okay, so if I put my theta here, we can rearrange this equation a little bit. And the reason I'm doing this is, again, I want y on one side and x on the other side, and something connected to the x on the other side, but I want it to still be dy dx. And when I used the method where you just flip it over, it didn't work. So now I'm trying a different method. So we're starting with what we were given in the question. Answers are here, so you can look if you want to go ahead at any time. And we know that first of all, we can divide by 3 on both sides. So we have x over 3 is tan theta. And then if we want to take tan to the other side, it's tan to the minus 1. So theta is equal to tan to the minus 1. We don't need this. I'm just showing you ways we can manipulate. Okay, but I'm going to use this one over here. And the reason I'm using this is because we go back to our SOHCAHTOA. SOHCAHTOA. Okay. So if tan theta is x over 3, then we know that I did something wrong there. TOA. Okay. We know that opposite over adjacent is x and 3, because this is opposite and this is adjacent. So this is just basic trig. Now we have to get the third side. We're using tan and we are heading towards sec, because that's in our dy dx, or sorry, our dx dy at the moment. And we know we're heading this way. Okay. So we know that sec is 1 over cos. So sec theta equals 1 over cos theta. So this you should know, it's the reciprocal of it. And so that's why I'm heading for sec theta. But for now, I still need to find my third angle here. And I can just use Pythagoras, which I know is x squared, because it's the hypotenuse, plus 3 squared square rooted. Okay. So we use Pythagoras to get that last angle there. So we're aiming for any type of answer that is the first derivative of our function and has sec in the answer, because we know that that's going to be the first derivative, and we can write it in terms of x instead of in terms of y. So just it's kind of a very logical way of sort of looking at this question. So I'm going to leave this up here. So if we had our dx dy, which was our original function, was this, just a pi over 6. And we know that we made this theta, if I rewrite it now, as y minus pi over 6. Okay. So let's rewrite this in terms of x. Now we have everything we need. We've made ourselves a 90 degrees triangle. And it's, so sec squared, well, let's start with sec of y minus pi over 6. Looking at our triangle would be equal to 1 over cos, oh, excuse me, y minus pi over 6. Okay. So if we look at this, we can replace this entire thing with its actual value. So this can be replaced with its actual reference. So cos would be from SOHCAHTOA, cos would be opposite of a hypotenuse. So it would be x over, I just want to leave that. X over square root x squared plus 3 squared. So this is the exact same thing as that. Okay. Oh, wait, what did I do? X. Need to write. So, it's adjacent. Okay. So, but remember that this is dx dy. It's not dy dx. So I'm going to flip it around. Then we get x squared plus 3 squared over 3. So this was just sec written out. And it's still not quite right because we needed, our dx dy needed to have a square in it and this 3. So whatever we do to it, we can do to the other side. So all I do is just, well, it needs to be squared and it needs to be times by 3. And this is actually dy dx. Excuse me, dx dy. Okay. I just want to check that I didn't double reverse this here. I mean, I'm looking at my working over here and it looks good. So sec theta is adjacent over, yeah, so sec theta is already reversed. So this is correct. This is the dx dy, not dy dx. So I'm just double checking that I didn't double up on my reversing. Okay. Once you get here, it's a little bit of algebra. So you can just finish it up. Just do square it, gets rid of the square root. So that square root is gone. And then we have x squared plus 9. The 3 squared is 9. All over 3 squared, which is 9. All of this is still times by 3. This 3 and this 9 can cancel out. We get 3 in the denominator. And of course, this is dx dy still. And finally, we have dy dx. Just flip it around. So it'll be 3 over x squared plus 9. Okay. So if you're like me and you make lots of common errors, just double check your work as you go, write lots of notes, but this is correct. So the sec becomes 1 over cos. You do the cos to get the dx dy, and then you have to flip it around at the end to have it dy dx with x in the answer. And this should be correct. If they just check what they asked for. So they asked for show this. They didn't necessarily ask for A and B. So you don't have to write what A and B are in the final answer. Okay, let's do number B. So this is, we're still doing number 7B. I wonder. Okay, I'm going to first do number 7B, and then for those of you who are interested, I'm going to do this trig identities approach that I looked at early on. So first, I'm going to do 7B though. So I'll give another version of 7A. Okay. For those who want to just stare at the answers first, this is 7B. Okay. Okay. So 7B says, gives new information. Point P lies on the curve. So I usually even in an exam, I write this. I say P, and then I say, if it gives a Y coordinate. So I say X, we don't know yet, but we know pi over 3 is the Y coordinate. So I would write that straight away. I would even write on C. I would write this in for myself. Given that the tangent to C at point P crosses the x-axis at point Q. Okay, so we know we have a curve, some sort of curve. And then we have a point P, some sort of P. And then we have a tangent, some sort of tangent. And we know that there is an x-axis there, and it crosses the x-axis at point Q. Okay, so we know that Q is going to be x0. So we know that because it crosses the x-axis, y is always 0. And the question is asked, what is the x coordinate of Q? Okay, so it wants this x coordinate. Now, given the information, first thing I would look at is obviously go in the order of the information that's given to answer these sorts of questions. So given the information that they've given you there, the first thing that they gave you is about a point that lies on C, and then they give you that it's a tangent. So I know that we're going to use this tangent somehow. Okay, I'm just trying to leave this question here for you. We know we're going to use this tangent information. So immediately I start thinking, like, what do I know about tangents? Usually we use the first derivative. We know that we had the first derivative from the part A of the question. So I already thinking to myself, well, I'm going to be using the first derivative from part A. So let me grab that information. I say, well, I know that the first derivative was actually 3 over x squared plus 9. Okay, so I know that my first derivative was equal to this. And I know that point P lies on both the curve and on this new tangent. So if I want to work out this tangent line, I can, because this is the first derivative is equal to the gradient of the tangent. So we have the tangent, although we would need an x value. So just bear that in mind. We would need some sort of x value, which we can work out. And then I'm thinking to myself, well, once we've got this tangent line, it'd be really easy to find out what it is there. So my first way of sort of doing this one would be to go for that tangent line and then take it from there. Okay, so I'll leave the answers up here for those who want to jump ahead. First thing I notice, obviously, is that we don't have the x value. Now, usually these questions would give you the x value. So first thing I need to sort out is I need to grab that x value. How do we do that? Well, we take the curve C and we sub in our y value. So C we had as, just grab it off here. Where's the curve? C, oopsie, C was written the other way around. So our C was x equals 3 tan y minus pi over 6. So we just, you can take this point C and just simply sub in y equals to pi over 3. Okay. And you choose, you can use this, you can do this yourself, or you can use your calculator. So if we sub in y equals pi over 3, then we can get our corresponding x value, which is quite simple. I already did this, so I'll let you work that out and have fun working that out. But let's see what I got when I subbed it in. I got point P as square root 3. That makes sense. Okay, so x is equal to square root 3, and now we have our correct x value. So in order to find the actual gradient of our tangent at point P, we have to sub in the x value at point P. Okay. So our P is square root 3, pi over 3. We're going to sub this into our gradient formula, which is also dy dx. So we're going to sub in just the x value in order to find the answer. It's equal to the gradient of the tangent. And we want that to be 3 over square root 3 squared plus 9, which I already worked out over there, comes to a quarter. Okay, so now we've got our gradient. We know that a tangent looks like this. Y equals mx plus c. We already have our m, so we have a situation with y equals a quarter x plus c. And the last step is we need to solve for our final unknown of c. So all we need to do is sub in some point for x and y. If we sub in some point for x and y, we'll have only one unknown, and then we'll be able to figure out what c is. And if I remember correctly, a point was given. Let's go back and see what I wrote down. Point Q was given as some sort of x and 0. That's got too many unknowns. In fact, that's the point that we're looking for, so that won't work. But we do have the whole of point P. We have the whole of point P now. So this is actually square root 3. So we can sub in point P into this equation. So let's go do that. Here we are. Sub in, I write this down, root 3, and it was pi over 3. And what that looks like is wherever you see a y, you put the y value. Wherever you see an x, you put the x value. And just take that across the equal sign. It would actually be root 3 over 4. That's what c. And I already worked it out. I got my c. I didn't actually write it in, but I just left it like that. Okay. So you can, this lazy teaching working. You should really just finish that off. But anyway, I'm going to leave it like that for now. So the question has asked for what is this point? And we have now this tangent. We have its formula. Okay, so the formula is y equals a quarter x, so the gradient a quarter, plus pi over, I left it exactly in this form. I didn't finish it up. Okay, so I just left it in the form that it was. This is my c value. So from here, you don't have to really do too much more. You know that at this point here, y is going to equal 0. Okay. Because it's an x-intercept. So we just have to let y equal 0. So to show the working, I'll put 0 on that side, quarter x, just writing it all in for you. Do this. Again, this is my kind of working, what I do. So those brackets don't really need to be there. I do that for teaching purposes. The reason I do that when I teach is because if there was a negative there, then the signs would change. Okay. So it's not, you don't need to write those brackets. It's simply for teaching purposes. But if I take them out because there wasn't a negative there, so the signs stay the same. All right. So we want to isolate x. We want x on its own. Quick rearranging, take the pi over 3 over, it'll be negative pi over 3. Take the square root 3 over 4 over, it'll be positive square root 3 over 4. So we have a quarter x. And then what I do is I just divide the whole thing by a quarter. That cancels out and we get x equal to whatever this ends up being. Okay. Mostly my students put this stuff in calculators. So it is, if you want to do it by hand, you would tip in times and you would get a common denominator with the 3 and the 4 and all of that stuff. But I'm not going to go into that in P3. I already did it, and the answer for x came to minus 4 pi's over 3 plus root 3. Okay, so this is the answer for the x where the tangent touches the x-intercept where the tangent touches, which I think is enough for this question. I think that's, let me just check. Yeah, that's finished question 7B. Fantastic.